Every calm night hides a violent past of shattering cosmic collisions. The silent stars above are survivors of a brutal history, a universe built from chaos. We are about to journey through the 25 most monumental crashes that forged reality itself. You will discover how the moon in our sky was born from a planetary wreck and how the gold in a ring came from a star explosion. What cosmic secret lies behind the serene face of our own galaxy? What force could one day reshape the entire night sky? How much of your own world is a direct result of ancient, unimaginable violence? By the end, you will see the cosmos not as a still painting, but as an endless, dynamic battlefield of creation and destruction. Are you ready to hear the true story written in the scars of space? Our story begins with the most colossal collision of all, the event that started everything. It was not an explosion in empty space, because space itself did not yet exist. Instead, think of a single, infinitely hot and dense point containing all the energy and matter of the entire universe. In an incomprehensible moment, this point began to expand at a phenomenal rate, creating space and time as it unfurled. This is the Big Bang. From that initial surge of existence, the universe cooled just enough for the most basic particles to condense out of the raw energy, first quarks and electrons, then protons and neutrons. The four fundamental forces of nature, gravity, electromagnetism, and the strong and weak nuclear forces, also emerged from this primeval fire, becoming the rules for every interaction that would ever follow. We are not just guessing about this. The evidence is literally all around us, a faint whisper of heat that fills the entire cosmos. This is the cosmic microwave background radiation, the cooled and stretched afterglow of that first fiery moment. It is the oldest light we can see, a fossil imprint on the sky from when the universe was a mere infant. Every galaxy, every star, and every atom in your body owes its ultimate origin to that singular, universe-forging collision. From that first cosmic dawn, the universe was a dark and simple place. For millions of years, it was just a vast expanding sea of hydrogen and helium gas, a featureless fog with no light. But gravity was already at work, a patient sculptor pulling on the faintest wrinkles in that primordial gas. Slowly, relentlessly, these clouds began to collapse in on themselves. As the gas compressed, the pressure and temperature at their cores skyrocketed to unimaginable levels. This was the moment the darkness ended, when the crushing weight of gravity ignited the first nuclear fires. The very first stars were born. These were not like the stars we see today. Astronomers call them population 3 stars, and they were true leviathans. They could be hundreds of times more massive than our own sun, burning with a ferocious, brilliant blue intensity. Their lives were spectacularly short and violent, lasting only a few million years before they exhausted their nuclear fuel. That end came not with a whimper, but with a world-shattering bang. These titanic stars did not just fade away. They tore themselves apart in colossal supernova explosions, so powerful they briefly outshone entire galaxies. And in that self-destructive fury, they performed their most crucial task. The intense heat of their cores and the violence of their deaths forged entirely new kinds of atoms. For the first time ever, elements like carbon, oxygen, and iron were forged in stellar furnaces and then blasted out across the cosmos. This was the universe's first chemistry set. The pristine hydrogen and helium were now seeded with the building blocks for everything to come. Every rocky planet, every molecule of water, and every atom in your body that is not hydrogen or helium was once forged inside one of these first, magnificent, and short-lived stellar giants. Their catastrophic deaths were the very events that made our material world possible. With the first stars gone, the universe was left with their chemical legacy and a new architectural blueprint. Tiny proto-galaxies, the seeds of future giants, began to form within vast webs of dark matter. This invisible scaffolding provided the gravitational anchor, pulling these fledgling islands of stars and gas toward one another. They did not drift apart in the expanding cosmos. Instead, they were drawn together in a slow cosmic dance that would end in a merger. This was the next great act of construction. These initial collisions were gentle by cosmic standards, a gradual coming together that built up the first true galaxies. Each merger added more stars, more gas, and more mass, steadily growing these structures from modest clusters into the magnificent spirals and ellipticals we recognize today. But these mergers did more than just make galaxies bigger. They also established their internal order. As two protogalaxies combined, their swirling gases collided and lost energy, funneling inexorably toward the new galactic center. This created a dense, bright core, a bustling central hub of stellar activity, and in that chaotic rush of infalling material, something else was growing in the dark. The gas that pooled at the center provided a feast for a mysterious object lurking there, a black hole. This was the birth of the supermassive black hole. These gravitational monsters, with masses millions or even billions of times that of our sun, did not form that big. They grew, and they grew rapidly, by devouring the torrent of gas delivered by these early galactic collisions. Every major merger pumped more fuel toward the center, allowing the black hole to swell to an immense size, so the very collisions that built the galaxies also planted and nurtured the enigmatic hearts within them. This established the fundamental architecture we see across the universe today, a grand design where nearly every large galaxy has a supermassive black hole residing silently at its core, a permanent reminder of those violent, formative years. This violent construction continued right in our own cosmic neighborhood. The early solar system was a shooting gallery of protoplanets, a chaotic dance of unstable orbits. Among them was a world named Theia, a body roughly the size of the planet Mars. Its path was a fateful one, a slow gravitational spiral directly toward a larger, still molten Earth. The impact was not a gentle sideswipe, it was a head-on collision of almost unimaginable force. When Theia struck, it did not just crash into the Earth. It merged with it in a cataclysmic event that vaporized a significant portion of our young planet's mantle and crust. The energy of the impact turned rock into a superheated plume of vapor and molten debris, a colossal splash of planetary material hurled out into the void of space. For a brief time, a glowing, donut-shaped ring of incandescent rock circled the wounded Earth, a testament to the violence of its birth. But in the cosmos, chaos often gives way to order through the patient pull of gravity. The debris within this ring could not remain scattered for long. The particles began to clump together, attracting one another, accreting into a single, larger body with startling speed, perhaps in a matter of only a few decades. From the fury of destruction, our moon was born. The consequences of this giant impact were profound and permanent. The sheer force of the collision set the young Earth spinning with a ferocious speed, likely giving our planet a day that was only 5 or 6 hours long. It also gifted our world with a stable axial tilt, that slight lean which gives us the gentle, predictable rhythm of the seasons. Without that stabilizing blow, Earth might have wobbled chaotically on its axis, creating a world of extreme and unstable climate shifts. Some scientists even theorized that the material Theia delivered could have included vital volatiles, the water and complex organic compounds that would later become the essential ingredients for life itself. So the next time you look up at the serene, silver face of the moon, remember its violent origin. It is not just a companion in our sky, it is a permanent scar, a piece of our own world torn away in a primordial crash that ultimately made Earth the living, stable world we call home. But that violent beginning was only the first chapter. The newly formed Earth and its infant moon entered a period of deceptive calm, a fragile truce in the chaos of the early solar system. For perhaps 400 million years, the inner planets seemed to be settling into their orbits. Then, without warning, the sky fell. A storm of fire and rock descended upon the young worlds, a cataclysmic event known as the Late Heavy Bombardment. For tens of millions of years, asteroids and comets pummeled the inner solar system in a relentless, planet-sterilizing barrage. The evidence for this ancient apocalypse is written on the face of our moon, whose ancient craters, untouched by erosion or tectonics, tell a story of a time when impacts were 1,000 times more frequent than they are today. Why did this happen after a period of relative peace? The answer lies in a slow-motion gravitational dance far out in the solar system. The leading theory, called the NICE model, paints a dramatic picture. Jupiter, Saturn, Uranus, and Neptune were not always in their current stable orbits. They drifted slowly over millions of years, their immense gravitational fields subtly tugging at one another. Eventually, Jupiter and Saturn fell into a special orbital rhythm, a resonance that sent powerful gravitational shockwaves through the entire planetary system. This resonance acted like a cosmic slingshot, violently hurling a vast, distant reservoir of icy planetesimals, a leftover swarm from the solar system's formation inward toward the sun. These frozen worlds became deadly projectiles, crashing into the inner planets with terrifying force. The consequences for Earth were profound and paradoxical. On one hand, this was a period of utter devastation. The largest impacts would have vaporized the early oceans and sterilized the entire planetary surface, boiling away any fledgling life that may have just begun to form. It was a global reset button, scorching the world clean. Yet from this destruction came the very ingredients for life's eventual success. Many of these incoming missiles were not rocky asteroids, but water-rich comets from the outer solar system. They were cosmic delivery trucks carrying vast quantities of water ice and complex organic molecules. With every world-shattering impact, these comets delivered precious water to our barren, rocky world, slowly filling the basins that would become our oceans. They also brought the building blocks of life itself, the amino acids and other compounds that would one day assemble into the first living cells. So this terrible bombardment, an epoch of fire that seemed to erase all hope, may have actually been the event that seeded our world with the water and the chemistry necessary for life to not just begin, but to ultimately thrive. 66 million years ago, a day that began like any other for the dinosaurs ended with a flash of light brighter than the sun. The asteroid, a mountain of rock and metal over 10 kilometers wide, pierced the atmosphere in an instant. It did not land in an ocean or a remote desert. It struck the shallow seas of the Yucatan Peninsula, and the planet itself screamed. The initial impact released more energy than all the nuclear weapons in the world combined. The rock at the point of collision was not just melted, it was vaporized, creating a fireball that expanded outward at hypersonic speeds, instantly incinerating every living thing for 1,000 kilometers in every direction. The ground, behaving like a liquid, rippled outward in a seismic shockwave that circled the entire globe. Within minutes, massive chunks of the Earth's crust were ejected into space, only to rain back down as superheated debris, heating the upper atmosphere to oven-like temperatures and triggering a global firestorm. Vast forests across the world spontaneously ignited. Then came the waves. The impact in the shallow sea displaced trillions of tons of water, sending mega tsunamis hundreds of meters high racing across the Gulf of Mexico, scouring coastlines clean of life and surging deep into the continents. But the most lethal effect was yet to come. The impact had struck a bed of sulfur-rich rock, blasting billions of tons of fine dust and sulfur aerosols high into the atmosphere. This created a shroud around the planet, a permanent sunless twilight. The impact winter had begun. For years, maybe even decades, photosynthesis ground to a halt. The global food web collapsed from the bottom up. Plants died, then the herbivores that ate them starved, and finally the great carnivores, the mighty Tyrannosaurus rex and its kin, perished. This was the Cretaceous-Paleogene extinction event. 75% of all species on Earth, from the iconic dinosaurs to countless marine reptiles and ammonites, were utterly wiped out. It was a planetary reset driven by a single random collision. Yet in the silent, empty world that followed, small, scurrying creatures emerged from their burrows. These early mammals, having survived the cataclysm, found a world of vacant ecological niches. The age of the dinosaurs was over. The path was now clear for the rise of the mammals, an evolutionary opportunity carved from the most devastating day in our planet's history. That planetary reset was a brutal reminder that our solar system is a dynamic and dangerous place. Yet for a long time, these colossal impacts were events we only reconstructed from ancient scars. All of that changed in the summer of 1994 when humanity got a front row seat to a cosmic demolition. Astronomers Carolyn and Eugene Shoemaker and David Levy had discovered a strange squashed comet the year before. It was not a single icy body, but a chain of 21 fragments like a string of pearls. This was Comet Shoemaker-Levy 9. Jupiter's immense gravity had already captured the comet on a previous pass and ripped it to pieces. Now on a final fatal trajectory, this entire cosmic train was headed directly for the gas giant. For the first time in history, scientists knew exactly when and where a major collision would occur in our solar system. Every telescope on Earth and even the Hubble Space Telescope in orbit was pointed at Jupiter, waiting. One by one, the fragments, some over 2 kilometers across, began their death plunge. They slammed into Jupiter's southern hemisphere at over 200,000 kilometers per hour. Each impact released an energy equivalent to millions of megatons of TNT. The fireballs they produced were hotter than the surface of the sun, rising thousands of kilometers above the planet's cloud tops before collapsing back in a terrifyingly beautiful plume. When the violence subsided, Jupiter was left scarred. The impacts had blasted enormous dark marks in its atmosphere, each one larger than our entire planet Earth. These bruises persisted for months, visible even through small backyard telescopes. This was not ancient history. This was happening right then in our own celestial backyard. The Shoemaker Levy 9 impact was a live broadcast of cosmic violence. It proved definitively that the solar system is still an active construction zone, where collisions of unimaginable power are not just relics of the past, but ongoing events that shape the worlds around us. That gold ring on your finger holds a secret more violent than any earthly forge. It was not born in the heart of a star. It was forged in the heart of a cataclysm so rare and powerful that for decades it was only a theoretical ghost. The origin of the heaviest elements, the gold, platinum, and even the uranium that powers our cities, had long puzzled scientists. A regular supernova, for all its ferocity, simply does not have the right conditions to create them. The true cosmic crucible for these precious metals is something far more exotic: the collision of two neutron stars. Imagine the core of a giant star, a structure so dense that a single teaspoon of its material would weigh billions of tons, collapsing into a sphere just a few miles across. That is a neutron star. When two of these incredible objects, locked in a final gravitational embrace, spiral into each other, they create a firestorm of creation. The collision, known as a kilonova, is a brief but unimaginably energetic event. For a few precious seconds, it outshines entire galaxies. In that maelstrom of ultra-dense matter, subatomic neutrons are slammed into atomic nuclei at an incredible rate. This rapid neutron capture process, or the R process, is what builds up the heaviest elements in the periodic table, atom by atom. The kilonova then acts as a cosmic scattergun, blasting this newly forged treasure, clouds of gold and platinum dust, out into the interstellar void at nearly the speed of light. This stardust then drifts for millions of years, eventually mixing with the gas clouds that form new solar systems. When our own Earth coalesced from such a cloud, it swept up some of that ancient, precious debris. So every ounce of gold on our planet, every piece of jewelry, and every gold reserve in a bank vault is quite literally the fallout from a cataclysmic collision that occurred between two dead stars long before our sun was even born. We're walking archives of the universe's most extreme violence, carrying pieces of that stellar wreckage with us every single day. Mercury holds a secret in its very structure, a puzzle written in its impossible density. This small world, the innermost planet, should be a dense ball of rock, yet it possesses a metallic core that is shockingly large, making up nearly 3/4 of its entire mass. It is as if someone peeled away the planet's rocky skin, leaving its metallic heart exposed to the void of space. The most compelling explanation for this strange anatomy is a violent and precise catastrophe in the solar system's youth. Early Mercury was likely a larger, more typical planet, with a healthy balance of a rocky mantle surrounding its iron core. Then came a planetesimal, a colossal body perhaps 1/6 of its mass, on a direct and devastating collision course. The impact was not a simple merger. It was a glancing blow of unimaginable force, a strike so powerful that it did not just crack the young planet open. It vaporized and blasted the majority of its rocky mantle clear off into space. The debris from that shattered shell was either captured by the sun's immense gravity or scattered across the inner solar system, leaving behind a planetary wreck, a stripped-down core that we now call Mercury. This single shattering collision directly forged the planet's extreme and hostile environment. With most of its insulating rocky blanket torn away, the planet's remaining core was left dangerously exposed. This explains the wild temperature swings that Mercury experiences today, from scorching 400 degrees Celsius on the sunlit side to a frigid negative 180 degrees Celsius on the night side. The planet simply lacks the mass and the rocky bulk to retain and distribute heat. Furthermore, that massive, partly liquid core is the engine for Mercury's other oddity, its weak but global magnetic field. While much weaker than Earth's, this field is generated by the churning of that immense ball of liquid iron, a dynamo set in motion by the very impact that defined the planet's fate. Mercury stands as a stark monument to a single perfect hit, a world whose entire identity was forged in a moment of catastrophic loss. While other planets spin like tops as they orbit the Sun, Uranus performs a bizarre, rolling wobble. Its rotational axis is tilted so dramatically that the planet essentially orbits on its side, with its north and south poles pointing toward the Sun at different points in its long year. This is not a gentle lean, it is a complete reorientation, as if the entire world had been knocked over. The most plausible explanation for this planetary peculiarity is a collision of staggering proportions. Early in the solar system's history, a young Uranus spinning normally was struck by a protoplanet roughly twice the mass of Earth. This was not a glancing blow. It was a direct cataclysmic hit that delivered a tremendous amount of angular momentum, literally tipping the entire planet onto its side and setting it into its current rolling spin. The debris from this colossal impact likely coalesced to form Uranus's system of rings and moons, which themselves orbit in the same tilted plane, a frozen record of that ancient impact. This extreme tilt has consequences that are almost beyond comprehension. A single season on Uranus lasts for 42 Earth years. Imagine this, for 42 long years, one pole is continuously bathed in sunlight, while the other is plunged into the absolute darkness and cold of deep space. Then as the planet continues its 84-year orbit around the Sun, the roles reverse. The sunlit pole enters its 4-decade-long night, and the frozen pole awakens to a 42-year-long day. This creates the most extreme seasonal cycle in our entire solar system, a rhythm of light and dark dictated by a single, world-altering collision from the dawn of time. The scars on Mars tell a story of planetary violence on an epic scale. Look at a topographical map of the red planet, and you are immediately struck by a stark division. The southern hemisphere is a rugged, cratered highland, while the entire northern third of the planet is a remarkably smooth, low-lying plain. This is the Borealis Basin, a colossal depression so vast it covers nearly 40% of the Martian surface. It is not a subtle feature, it is a planetary wound, and the most compelling explanation for its existence is a single, devastating impact from a protoplanet roughly the size of the dwarf planet Ceres. This was not a mere crater, this was a blow that redefined an entire world. The impactor, traveling at cosmic speeds, would have struck the young Mars with unimaginable force, blasting away a significant portion of the planet's crust and mantle in a single planet-altering moment. The event likely occurred during the same chaotic period of the late heavy bombardment that pummeled Earth and the Moon, but the consequences for Mars were uniquely catastrophic. The immediate aftermath was a world in agony. The impact would have generated enough heat to melt the crust globally, creating a temporary magma ocean. But the real lasting damage was far more insidious. The cataclysm may have delivered a death blow to Mars's planetary dynamo, the churning liquid iron core that generated its global magnetic field. The shock of the impact could have disrupted the core's delicate convective motions, causing the magnetic field to falter and then fail. Without this protective magnetic shield, the young Martian atmosphere was left utterly exposed to the relentless fury of the solar wind. This stream of charged particles from the Sun began to strip the atmosphere away, molecule by molecule, in a slow-motion planetary suffocation. As the atmospheric pressure dropped, the vast oceans and rivers that once flowed across the northern plains could no longer remain liquid. The water either evaporated into space or retreated deep underground, freezing into permafrost. What was once a warm, wet world, potentially hospitable to life, was transformed over billions of years into the cold, desiccated desert we observe today. The Borealis Basin is more than just a giant hole. It is the ghost of a planetary murder weapon, the site of a collision that stole a world's atmosphere, its water, and perhaps even its chance at a living future. Those two lumpy shadows tumbling around Mars have always seemed out of place. Phobos and Deimos are tiny, irregular, and dark, looking far more like captured asteroids than natural-born moons. For decades, the simplest explanation was that Mars gravity simply snagged two passing rocks from the nearby asteroid belt, but this tidy story is now unraveling. The orbits of Phobos and Deimos are nearly circular and align almost perfectly with Mars' equator, a level of order that is incredibly difficult to achieve through a random capture. It is the equivalent of a planet rolling out a perfect red carpet for two strangers. A far more violent and elegant origin story is gaining ground, one that connects these small moons to the colossal impact that carved the Borealis Basin. The same cataclysm that may have stripped Mars of its atmosphere could also have given it its children. The theory suggests that when the protoplanet struck Mars, it did not just blast away the northern crust. It also hurled an immense plume of vaporized rock and debris high into orbit around the young planet. This material quickly coalesced into a vast, thin ring, a glowing disk of destruction encircling the wounded world. Within this ring, larger chunks began to form, accreting from the smaller particles. The largest of these aggregations may have been a single, substantial moon that has since spiraled inward and crashed back onto Mars. But farther out, two smaller, rubble pile objects managed to stabilize. These are Phobos and Deimos, not captured strangers, but the recondensed remnants of Mars itself, born from the very material of their parent planet in a moment of supreme violence. This would make them close cousins to our own moon, another world forged from planetary collision. Future missions hold the key to solving this mystery. The Japanese Space Agency's Martian Moons Exploration Mission, or MMX, is planned to launch later this decade, with the explicit goal of visiting Phobos, landing on its surface, and collecting a sample to bring back to Earth. The chemical analysis of that material will be the ultimate test. If the rocks of Phobos match the unique composition of Mars, the capture theory will be laid to rest forever, confirming that even these small, dark moons are permanent scars from a planetary trauma that reshaped an entire world. Saturn's rings are a cosmic illusion of perfect serenity. From afar, they appear as a smooth, solid disk of polished stone, a celestial hula hoop draped around the gas giant. But this is a lie. Those magnificent bands are not solid at all. They are a frenzied, chaotic blizzard. Trillions of individual chunks of water ice, ranging in size from tiny snowflakes to mountains as large as houses, are all racing around the planet in their own frantic orbits. How did this beautiful, chaotic disk come to be? The most compelling story is one of celestial murder. The rings are likely the ghost of a shattered moon. Perhaps a large icy moon, similar to Saturn's own Enceladus, drifted too close to its parent planet over hundreds of millions of years. There is a point around every giant planet known as the Roche limit, a zone where the planet's gravitational pull becomes stronger than the gravitational forces holding a moon together. Inside this boundary, a moon is no longer safe. As this ill-fated moon crossed that threshold, Saturn's gravity began to pull harder on its near side than its far side. This tidal force stretched the moon, warping it into an oval, then pulling it apart strand by strand. The moon did not simply crack, it was systematically shredded into a cloud of rubble, its icy fragments spreading out along the moon's original orbital path. Another possibility is that a large, wandering comet was the victim, captured by Saturn and torn to pieces in the same violent manner. The evidence for a relatively recent destruction lies in the rings themselves. They are incredibly bright and pristine, reflecting sunlight with a brilliant white gleam. If they were as old as the solar system, over 4.5 billion years, they should have been darkened by eons of accumulated cosmic dust. Their youthful appearance suggests this cataclysm may have occurred as recently as 100 million years ago, a time when dinosaurs still roamed the Earth. This means Saturn's iconic rings are a temporary masterpiece. They are a vivid, ongoing demonstration of the destructive power of gravity, a frozen moment from a much more chaotic era in our solar system's history, and a reminder that even the most beautiful structures in the cosmos are born from violence. Far out in the cosmos, a star system is still ringing from a recent planetary demolition. Around the young star HD 172555, astronomers have found something extraordinary. Not the gentle dust of a forming world, but a vast swirling cloud of vaporized rock. This is the forensic evidence of a hypervelocity collision, a crash between two protoplanets, each likely the size of our own Earth, moving at speeds over 20,000 miles per hour. The impact was so violent it did not just shatter the two worlds, it flash vaporized their surfaces, turning solid rock into a seething fog of silica gas. Imagine two continents of granite slamming into each other with such force that they instantly transform into a superheated cloud. That is the scale of destruction we are witnessing in this distant system. This discovery gives us a stunningly direct look at the chaotic process of planet building. We are not just theorizing about ancient collisions in our own solar system's past. We are observing the same violent process unfolding in real time around another star. The sheer amount of silica dust detected tells a story of unbelievable energy, a planetary scale explosion that would have outshone its parent star for a brief, brilliant moment. This cosmic smash-up is a powerful reminder that the serene planetary systems we see today are the lucky survivors of a brutal and chaotic youth. For every stable world like Earth, there were countless others that met a far more violent end, their material scattered back into the cosmic cloud from which new worlds will one day be born. South Africa holds the ghost of the most powerful punch our planet has ever endured. Deep within its landscape lies the Vredefort Dome, a sprawling, weathered ring of hills over 300 kilometers across. To the untrained eye, it is just a beautiful, undulating landscape, but this is the deeply eroded scar of an impact so colossal, it makes the dinosaur-killing asteroid seem modest by comparison. Over 2 billion years ago, an asteroid between 15 and 20 kilometers wide, a mountain of rock and metal moving at cosmic speed, slammed into the Earth. The energy released in that single moment was beyond any volcanic eruption or earthquake. It was a planetary-scale detonation. The initial fireball would have vaporized the shallow oceans of the primordial world and instantly melted the crust down to a depth of many kilometers, creating a temporary sea of liquid rock hundreds of kilometers wide. The seismic shockwaves would have rung the entire planet like a bell, triggering global volcanic eruptions and reshaping the very continents that were only just beginning to form. Studying the Vredefort impact is not just about understanding a single ancient disaster. It provides a crucial data point for one of the most important questions in planetary science. How often does life on Earth face an existential threat from the sky? By dating this crater and comparing it to others, scientists can calculate the average frequency of these civilization-ending impacts. Vredefort tells us that over the vast expanse of geologic time, such world-shattering events are not freak accidents, but a predictable part of living on a planet in a busy solar system. It is a sobering reminder that the peaceful skies we enjoy today are a temporary gift, punctuated by rare but inevitable cataclysms from the depths of space. Another planetary scar lies deep in the Canadian Shield, a sprawling geological wound known as the Sudbury Basin. Formed 1.8 billion years ago, this is the second largest confirmed impact crater on our planet. The asteroid that created it was a true monster, likely over 15 kilometers in diameter. Its impact was so profoundly violent that it did more than just excavate a hole in the crust. It punched all the way down, fracturing the planet's outer shell and bringing up material from the very boundary of the Earth's mantle. For a brief, terrible moment, the inner workings of the world were exposed to the open air. The initial crater was a hellscape of molten and shattered rock, hundreds of kilometers across, but in the millions of years that followed, this site of absolute destruction began a slow transformation. The immense heat and pressure from the impact, combined with the deep-seated magma that welled up into the fractured crust, triggered a unique geological alchemy. The subterranean fluids, rich in metals, began to circulate through the broken rock. As the crater cooled, these incredibly valuable minerals, primarily nickel and copper, along with precious platinum group metals, did not simply disperse. They settled and concentrated in specific layers, creating some of the richest ore deposits ever discovered on Earth. Today, the Sudbury Basin is one of the planet's most important mining districts. The very same cataclysm that once vaporized this landscape now provides the essential metals that build our infrastructure, power our electronics, and grace our jewelry. Every time you pick up a nickel coin or use a device with copper wiring, there is a chance you are holding a piece of that ancient, planet-altering collision. This is not just a scar on the map, it is a vibrant working mine, a direct and ongoing economic legacy written by a cosmic event from a billion years before the first dinosaurs walked the Earth. A century ago, a flash of light tore through the sky above a remote Siberian wilderness. On June 30th, 1908, a fireball brighter than the sun raced over the Tunguska River basin. The event that followed was not an impact, but an atmospheric explosion of unimaginable force. A small asteroid or a fragment of a comet, perhaps only 60 meters across, entered Earth's atmosphere at hypersonic speed. The pressure and heat were too much for the rocky body to withstand. It detonated in a massive airburst several kilometers above the ground, releasing energy equivalent to a large hydrogen bomb, between 10 and 15 megatons of TNT. The effect on the land below was absolute devastation. A shockwave of superheated air radiated outward, flattening over 2,000 square kilometers of ancient forest. 80 million trees were snapped like twigs and thrown down in a radial pattern, all pointing away from the epicenter of the blast. The explosion was heard over 1,000 kilometers away, and the seismic rumble was registered on instruments as far as England. For days, the night skies across Europe and Asia glowed with a strange silvery luminescence, as dust from the vaporized object high in the atmosphere reflected sunlight around the globe. When expeditioners finally reached the remote site years later, they expected to find a massive crater. They found none. The absence of a crater was the event's greatest mystery, a puzzle that baffled scientists for decades. How could such destructive power leave no mark on the ground? The answer was the airburst itself. The entire asteroid had vaporized in the sky, its substance scattered as fine dust across the upper atmosphere. The Tunguska event serves as a sobering modern warning. This was not a dinosaur-killing asteroid. It was a relatively small object, a cosmic pebble. Yet its energy release was hundreds of times more powerful than the atomic bomb dropped on Hiroshima. If such an event had occurred over a populated city center, the entire metropolitan area would have been erased from the map in an instant. It underscores a terrifying reality. The threat from near-Earth objects is not just about global extinction events. It is also about regional catastrophes that could happen at any time, with little to no warning. The silent, empty forest of Tunguska stands as a monument to our planet's vulnerability, a stark reminder that the next cosmic collision might not be a question of if, but when. The silent Siberian forest was a stark warning, but humanity did not truly listen until a Monday morning in February 2013. Over the city of Chelyabinsk, Russia, the sky suddenly held a second sun, a fireball so brilliant it cast sharper shadows than the real sun itself. This was a 20-meter wide asteroid, a cosmic rock roughly the size of a 6-story building, entering the atmosphere at 60,000 kilometers per hour. It was completely undetected, arriving from the direction of the sun, which blinded our telescopes. For 30 long seconds, it tore a flaming path across the sky, captured on dozens of car dashcams and security cameras by a population simply on their way to work or school. Then at an altitude of about 30 kilometers, it could take the strain no longer. It exploded in a massive airburst, releasing energy equivalent to about 500 kilotons of TNT, over 30 times the power of the Hiroshima bomb. The shockwave took a full minute to reach the ground. When it did, it shattered windows in thousands of apartment buildings, sending razor-sharp glass flying into homes, offices, and schools. Over 1,500 people were injured, most by this flying glass, in a sudden and terrifying reminder that the cosmos can reach out and touch us without any warning. The event caused widespread property damage and sheer panic, yet it was a cosmic near-miss. Had the asteroid entered at a steeper angle, the airburst would have been lower, and the destruction would have been far, far worse. Chelyabinsk was not a global extinction event. It was a cosmic warning shot, a direct hit on our collective sense of security. It proved that even small, undetected objects can deliver a devastating punch, and that our current planetary defense systems are full of blind spots. The question it left hanging in the air is as urgent as it is terrifying. When will the next one come, and will we see it in time? A brilliant tapestry of destruction and creation unfolds 2.2 million light-years away. This is the Antennae Galaxies, a pair of majestic spirals caught in a slow-motion car crash of cosmic proportions. Their elegant structures are gone, twisted and torn by the relentless pull of their mutual gravity. The most spectacular evidence of this violence are the two long, sweeping arcs of stars flung far out into intergalactic space, the titular antennae that give the system its name. These are tidal tails, streams of stellar material ripped from the galaxy's outer edges and drawn out like cosmic taffy, a beautiful scar from their gravitational dance. But the true fireworks are happening deep within the merging hearts of the two galaxies. As their immense clouds of hydrogen gas collide, they are being compressed with unimaginable force. This cosmic pressure cooker has ignited a firestorm of starbirth, a stellar baby boom of epic scale, hundreds of massive, brilliant star clusters, each containing millions of newborn suns, blaze with a fierce blue-white light. The Hubble Space Telescope's iconic image of this system captures this frenzy of creation, a chaotic ballet of dust, gas, and nascent solar systems. This is not just a spectacle from the distant past. It is a preview of a future written in the motion of our own night sky. The Andromeda Galaxy, that faint, fuzzy smudge we can see with the naked eye, is on a direct collision course with our Milky Way. The two galaxies are hurtling toward each other at a speed of over 100,000 kilometers per hour. In roughly 4.5 billion years, they will meet, and the serene spiral we call home will cease to exist. Our distant descendants, if any remain, will witness a sky transforming. The calm band of the Milky Way will warp and distort as tidal forces pull stars into new, chaotic paths. The two galactic cores will swing past each other in a series of close encounters, their supermassive black holes destined to eventually merge, and just like in the antennae, the collision will trigger an immense burst of star formation, lighting up the galactic center with the birth of countless new suns. Our own solar system will likely be flung into a new, more distant orbit, a cosmic passenger on a ride through a reshaped galaxy. The familiar constellations will be scrambled beyond recognition, replaced by a brilliant, chaotic display of creation born from the ultimate collision. The serene dance of galaxies hides a deeper, invisible truth. For decades, astronomers had a problem. The way galaxies moved and clustered together suggested there was far more mass in the universe than they could actually see. They called this missing ingredient dark matter, a ghostly substance that neither emitted nor absorbed light, revealing itself only through its gravitational pull. It was a compelling theory, but it needed proof. That proof arrived in the form of a cosmic catastrophe, the Bullet Cluster. This system is the aftermath of a high-speed collision between two massive galaxy clusters, each containing hundreds of galaxies. The collision happened at millions of miles per hour, a truly staggering event. But the real discovery was not in the galaxies themselves. Galaxies are mostly empty space, so when two clusters collide, the stars within them pass right by each other like two swarms of bees, unaffected. The hot gas that fills the space between the galaxies, however, is a different story. This superheated plasma is the majority of the normal, visible matter in a cluster. When the clusters smashed together, this gas collided and slowed down dramatically, like two clouds of smoke merging and getting tangled. This left the gas lagging behind in the center of the system. The galaxies, both the visible stars and the unseen dark matter, sailed right on through. So how did we map the invisible dark matter? We used gravity itself as a lens. Astronomers observed how the immense mass of the cluster warped the light from even more distant galaxies behind it, a phenomenon called gravitational lensing. When they mapped this distortion, they found the bulk of the mass was not where the visible gas was pooled in the center. It was out with the galaxies in two distinct clumps that had passed through the collision completely unscathed. This was the smoking gun. The majority of the mass was completely invisible and did not interact with anything, not even itself. It simply passed through the cosmic wreck, its gravity the only sign it was ever there. The Bullet Cluster provided the first direct visual evidence that dark matter is real. It is not a modification of gravity or a flaw in our theories. It is a substance, a mysterious fabric that holds the universe together, and its discovery in the wake of a colossal collision forever changed our understanding of what the cosmos is truly made of. Sometimes the most beautiful objects in space are the strangest. A billion light years away, a celestial oddity known as NGC 7252 drifts, a galaxy nicknamed Atoms for Peace for its faint, nuclear-powered resemblance to the classic symbol. Its true nature is far more violent. This is the ghost of a collision between two spiral galaxies that have completely merged, their structures now blended into a single, chaotic, and breathtakingly beautiful entity. The most startling feature of this galactic hybrid is a small, bright disk of stars spinning at its very heart. This central disk is not following the rotational lead of the larger galaxy. It is spinning in the exact opposite direction, a cosmic rebellion frozen in time. This counter-rotating core is the direct result of the merger, a final pocket of gas and stars that fell into the center with a different angular momentum than the rest of the incoming material. It is like a whirlpool spinning backwards inside a larger whirlpool, a lasting signature of the chaotic forces that created it. Surrounding this strange heart is a spectacular halo of youth. More than 500 brilliant young star clusters swarm around the galaxy, each one a massive collection of blue-white suns burning with fierce, newborn intensity. These clusters are the children of the collision, born when the immense clouds of gas from the two spirals slammed together and collapsed under the shock. They are the stellar equivalent of a sudden, massive baby boom, illuminating the galactic wreckage with the light of their creation. The Atoms for Peace galaxy defies every simple category. It is not a spiral, nor is it a standard elliptical. It is a unique and transitional object, a living museum of a recent merger. It shows us that galactic collisions do not just create destruction or trigger star birth. They can also forge entirely new kinds of structures, bizarre and beautiful systems that operate by their own unique rules, reminding us that the universe's capacity for invention through violence is truly limitless. Our own galactic home is not an island, but a ship on a collision course. The serene spiral of the Milky Way and the faint smudge of Andromeda are linked by an unbreakable gravitational tether, pulling them together at over 250,000 miles per hour. In about 4.5 billion years, this cosmic dance will enter its final, breathtaking act. The approach will be achingly slow from our human perspective, but the transformation of the night sky will be relentless. At first, Andromeda will simply grow larger, its spiral arms becoming more distinct. Then, as it draws nearer, its gravity will begin to warp the familiar band of our own Milky Way, pulling and twisting it out of shape. The sky we have known for all of human history will become unrecognizable. The two galaxies will not hit head-on, but swing past each other in a series of close gravitational encounters. Stars will be flung into new, chaotic paths like sparks from a celestial wheel. During this billion-year-long dance, the real drama will unfold at the very center. The supermassive black holes at the hearts of both galaxies, each weighing millions of suns, will begin their own deadly waltz, spiraling toward an eventual merger that will shake the fabric of spacetime itself. And just as we witnessed in the antennae galaxies, this violence will trigger a firestorm of creation. The colossal clouds of gas and dust from both systems will slam together, compressing and igniting to form billions of brilliant new stars, lighting up the galactic core in a stellar renaissance. The final product of this epic merger will be a new type of galaxy, a vast, featureless elliptical blob often nicknamed Milkdromeda. Our solar system will likely be flung far out into this new galactic halo, a safe passenger on a wild ride. And here is the most reassuring fact in this grand upheaval. Despite the titanic forces at play, the actual stars within the galaxies are so far apart that it is incredibly unlikely any two will physically collide. The emptiness of space is our greatest protector. You will still have a sun in the sky, but the constellations will be gone forever, replaced by a dazzling, alien sky filled with the combined light of two merged galaxies. It is the ultimate fate written in the silent motion of the stars, a future where the sky itself is a monument to a collision of almost biblical proportions. Every single planet you know was built by violence. The serene orbits of our solar system hide a brutal past, a construction zone where the only building blocks were collisions themselves. This fundamental process is called accretion, and it is the story of how chaos built worlds. It all began with the faintest of touches, in the disk of gas and dust swirling around our infant sun. Microscopic particles of dust, no larger than specks of smoke, drifted toward one another. Static electricity, a faint whisper of a force, made them stick. A speck became a grain became a pebble. These tiny collisions were gentle, but they were constant, a slow-motion snowball fight happening in the void. As these pebbles grew, their gravity, however minuscule, began to exert a tiny pull. They gathered more dust, more pebbles, becoming rocky bodies the size of mountains. These were the planetesimals, the true planetary embryos. Their collisions were no longer gentle. They were crashes of rock and ice, mergers that built ever larger bodies in a chaotic, high-stakes game of gravitational billiards. Think of the asteroid Vesta or the dwarf planet series. These are surviving planetesimals, frozen relics of that early construction phase. For millions of years, these protoplanets crisscrossed the young solar system, their orbits unstable and overlapping. Some collisions were gentle mergers, adding mass and building up the core of a future world like Earth or Mars. Others were shattering impacts like the one that may have stripped Mercury of its mantle, breaking bodies apart and resetting the clock. This was a violent and inefficient process. For every successful merger, there were countless destructive crashes that scattered material back into the cosmic cloud. The gold in your jewelry, the iron in your blood, every atom of rock and metal under your feet was part of this endless cycle of collision and assembly. The very ground you stand on is the ultimate survivor of a cosmic battlefield, a testament to the trillions upon trillions of collisions that, against all odds, built a stable and living world. This creative force of accretion is not unique to our solar system. It is the universal rule. Every exoplanet we discover, every distant world orbiting another star, was forged in the same fiery crucible of relentless world-building impacts. This grand cycle of creation and destruction leads us to the final, ultimate collision, one that will encompass the entire cosmos. Billions of years from now, the fate of everything we have ever known rests on a single, fundamental question. Will the universe continue expanding forever, or will gravity eventually win the long cosmic tug-of-war? The answer to this question points toward two profoundly different endings. The first is the heat death, a quiet, cold, and lonely finale. In this scenario, the expansion of the universe continues unchecked, accelerating until galaxies are torn apart from one another, their stars burning out one by one. Even the black holes will slowly evaporate over near infinite time, leaving behind a universe that is a thin, dark, and lifeless soup of subatomic particles, where the temperature approaches absolute zero and no energy can ever flow again. It is the ultimate dissipation, a final state of maximum entropy where no collisions can ever happen again. The other possibility is the Big Crunch, the ultimate cosmic collision. If there is enough matter and dark energy weakens, the collective gravity of the entire universe could one day halt its outward rush. The expansion would slow, stop, and then reverse. Every galaxy, every star, every atom would begin falling back toward everything else. The cosmos would rush inward in a mirror of the Big Bang, a great cosmic implosion. The temperature of the universe would skyrocket as all of space is compressed into an increasingly smaller, hotter, and denser state. In the final moments, the entire universe will be crushed back into a single, infinitely hot and dense point, a singularity. This is the ultimate collision, a moment where everything that ever was or could be smashes together into one, and in that cataclysm, some theories suggest the conditions might be right for a rebirth. The incredible energy of the Big Crunch could trigger a new Big Bang, birthing a brand new universe from the ashes of the old, potentially starting the entire cycle of cosmic collisions all over again. Whether our universe ends in ice or in fire, its final act will be written by the same force that has shaped it from the very beginning, the endless, dynamic dance between the urge to fly apart and the primal pull to come together. The silent, cold threat from space is not confined to history. Right now, as you watch this, thousands of known asteroids and comets are navigating orbits that bring them unsettlingly close to our own path around the sun. These near-Earth objects are the leftover debris from the solar system's violent construction, and their trajectories are a permanent part of our celestial environment. The question is not if another will strike, but when and whether we will be prepared. This is not a plot for a science fiction film. It is the daily focus of a dedicated team of scientists and engineers at NASA, a Planetary Defense Coordination Office. Their mission is as straightforward as it is profound: to find these objects before they find us. They constantly scan the skies, tracking and cataloging what they call potentially hazardous objects, asteroids and comets large enough and close enough to pose a credible threat to Earth. But tracking is only the first step. Knowing a rock is coming does not stop it. For the first time in our planet's history, a species is developing the capability to fight back. Humanity has taken its first real step toward active planetary defense. The DART mission, the Double Asteroid Redirection Test, was a groundbreaking experiment. A spacecraft was deliberately flown into a small asteroid called Dimorphos, which was orbiting a larger asteroid named Didymos. The goal was not to destroy it, but to give it a gentle nudge to see if we could ever so slightly alter the path of a celestial body. The result was a spectacular success. The impact shortened Dimorphos' orbit, proving that we can, in fact, change the trajectory of an asteroid. This kinetic impactor technique is just one possible tool. Other ideas are on the drawing board, from gravity tractors that would use a spacecraft's own slight gravitational pull to slowly tug an asteroid off course, to focused ion beams that could push it away over time. We are no longer just passive passengers on a planet hurtling through a cosmic shooting gallery. We are learning to become pilots, taking the first tentative but crucial steps to steer our world away from danger. The next time you look up at the night sky, you can do so with a new sense of agency. The same cosmic collisions that built our world and shaped our history may one day be prevented by the very intelligence that evolution, born from those ancient impacts, has produced. Our journey through cosmic history reveals a single unifying truth. From the primordial fire of the Big Bang to the majestic spirals of distant galaxies, creation is born from destruction. The very atoms that form our bodies and our world were forged in the hearts of exploding stars and the violent mergers of dead suns. That silver moon hanging in our night sky is a permanent monument to a planetary crash that stabilized our climate. Every beautiful ring around a distant planet is the ghost of a shattered moon. Even the gold in a wedding ring is stardust, the literal fallout from a neutron star collision that occurred billions of years before our sun ignited. We are not just observers of this cosmic drama, we are a product of it, living archives of the universe's most violent and creative moments. This grand story invites us to look up at the night sky with entirely new eyes. See it not as a static painting, but as a dynamic, ever-changing battlefield where chaos and beauty are two sides of the same coin. The serene darkness is filled with the echoes of ancient impacts and the promise of collisions yet to come. We would love to hear which of these cosmic crashes captured your imagination the most. Was it the impact that gave us our moon, or the galactic merger that first proved the existence of dark matter? Share your thoughts in the comments below, and let us continue to explore this violent, beautiful universe together.